Hi everyone, welcome to the Function Junction, where we make math simple and easy to understand. Today we'll learn how to graph linear equations using slope and intercept. By the end of this video, you'll understand what slope really means, how to find it from any equation or 2 points, and how to draw your graph correctly. Let's start with what exactly is a linear equation. Well, a linear equation shows a straight line relationship between x and y. It is written in the form y equals mx plus b. Let's break down each variable in this equation to get a better understanding. First, we have m. M represents the slope of the line. The slope controls how steep the line is, which is the line's rise over run. We'll go into this deeper in the next slide. Next, we have b. B represents the y-intercept. This tells us where the line crosses the y-axis. So what exactly is the slope? As we just mentioned, the slope measures how steep a line is, or in other words, how much y changes for every change in the x. We use the equation shown on the screen, which is m equals rise over run, which we break down further to y2 minus y1 over x2 minus x1. This means that rise is the difference in the y, which is the vertical distance between the 2 points, and run is a difference in the x, which is the horizontal. When we divide the two differences, we get the slope of the line. It's important to note the following when graphing linear equations. If rise and run are both positive, then we will have a line that goes up. If rise is negative, then our line goes down. If rise is equal to 0, then we have a horizontal line. If the run is equal to 0, then we have an undefined slope, which is shown by a vertical line. Before going into an example, let's outline some steps to help graph a linear equation. Step 1. Identify the slope m. When looking at an equation, m is always before the variable x. Step 2. Find the y-intercept and plot a point on the grid. Based on the equation y equals mx plus b, we know our y-intercept is the constant in the equation. That number represents the value our point has in the y when x is equal to 0. Knowing that, we can plot our first point on the graph. Step 3. Find the next point using the slope identified. Knowing how much the line rises in the y and runs in the x, we can plot the second point. Step 4. We connect the dots to produce our line. Let's look at our first example. Plot the graph for the equation y equals 2x plus 1. Using the steps we previously outlined, let's start solving. Step 1. Identify m. Knowing the equation y equals mx plus b, we can see that m equals 2. Since m is a positive number, we know our graph will be a line that goes up. Step 2. Find the y-intercept and plot our first point. By referencing our formula, we can see that our value for b is 1. Knowing that, we can plot our first point. It's important to note that b represents the value in the y of our point on the graph when x is equal to 0. Therefore, our first point has the coordinates 0, 1. Step 3. Use the slope to find the next point. We found our slope to equal 2, and we know that slope is equal to rise over run. Therefore, we can see that our graph will have a rise of 2 and a run of 1. So on our graph, starting at our first point, we will move up 2 units and move 1 unit to the right. The value of our new point will be 1, 3. Our last step will be to connect the dots so we can complete our line. Let's take a look at another example. Plot the graph for the equation y equals negative 1 over 2x plus 2. Step 1 is identify m. Knowing the equation y equals mx plus b, we can see that m equals negative 1 over 2. Since m is a negative number, we know that our graph will be a line that goes down. Step 2. Find the y-intercept and plot our first point. By referencing our formula, we can see that our value for b is 2. Knowing that, we can plot our first point, which will be 0, 2. Step 3. Use the slope to find the next point. We found our slope to equal negative 1 over 2. So using rise over run, we can see that our graph will have a rise of negative 1, meaning the graph will go down 1 unit, and a run of 2. So on our graph, starting at our first point, we will go down 1 unit and move 2 units to the right. The value of our new point will be 2, 1. Our last step will be to connect the dots so we can complete our line. Now that we know how to graph our line when the slope is known, let's learn how to find the slope when given 2 points. Using the slope formula, we can find the slope and write the equation. Let's take a look at an example to get a better understanding. Find the slope between the points 1, 2, and 2, 5. First, let's substitute our x and y coordinates into our formula. M equals 5 minus 2 over 2 minus 1. This means that we have a slope of 3. We can plot both points we were given and connect them to form our line. And now we can visually see the relationship that for every 1 unit, our line moves right, y increases by 3. Let's do a second quick example with a negative slope. Find the slope between the points 3, 4, and 5, 2. First, let's substitute our x and y coordinates into our formula. We get m equals 2 minus 4 over 5 minus 3. This means that we have a slope of minus 1. When we plot our points on the graph, we can see that for every 1 unit our line moves right, y decreases by 1. Let's take a look at some special cases. Our first case is when m is equal to 0. In this case, we would see a horizontal line, which means that our y is constant. 0 slope means no rise. If we take a look at an example, y equal to 3, we plot a horizontal line through y equal to 3. It's important to note that this equation is still in the format y equals mx plus b. But because we have a 0 slope, the mx part of the equation is removed, leaving y equal to 3. In our second special case, we have m as an undefined slope. This results in a vertical line, meaning our x is constant. Undefined slope means no run. For example, x equal to 2. We plot a vertical line through x equal to 2. Not every equation's already in the form y equals mx plus b. To graph it, we need to isolate y first. Let's look at an example to learn this. Graph the equation 2x plus y is equal to 4. First step is to isolate y. To do so, we'll subtract 2x from both sides. This leaves us with y is equal to minus 2x plus 4. Now the equation's in a format that we are familiar with, and we can proceed with our usual process. We can see that m is equal to minus 2. Since m is a negative number, we know what our graph will look like. It will be a decreasing line. Next, we need to find the y-intercept and plot our first point. By referencing our formula, we can see that our value for b is 4. Knowing that, we can plot our first point, which will be 0, 4. Now we will use the slope to find the next point. We found our slope is equal to minus 2. So using rise over run, we can see that our graph will have a rise of minus 2, meaning the graph will go down 2 units, and a run of 1. So on our graph, starting at our first point, we will go down 2 units and move 1 unit to the right. The value of our new point will be 1, 2. Our last step will be to connect the dots so we can complete our line. You may be wondering, what are the applications of this? Or why is slope important for me to know? Well, slope is everywhere. Roads, ramps, and even charts, just to name a few. For example, we can use y equal to 3x plus 2 to represent the total cost of something. In this case, the slope, which is 3, means that every additional x adds $3 to the total cost. Try solving this one on your own and let me know in the comments how it went. That brings us to the end of the lesson. Let's summarize what we've learned. We learned that slope is equal to rise over run, which is equal to y2 minus y1 over x2 minus x1. A positive slope means our line rises. A negative slope means our line falls. A 0 slope produces a horizontal line, while an undefined slope produces a vertical line. Lastly, we learned to always start with y equals mx plus b when graphing our linear equation. Congratulations! Now you can find and graph the slope of any linear equation. If you like this video, make sure to subscribe. Also, make sure to check out our other videos to continue your function junction journey. See you next time!